the y-axis, and time on the x-axis. This will be in hours. This will be in miles. Extra conversation isn't necessary.
I do that with my picture?
Yeah.
Okay.
And we're going to keep it, again, we're going to keep it really simple just for demonstrative purposes. We're going to say 1, 2, 3, 4 hours. Yeah, I'll put another one.
Is it supposed to be in a cube or
Right. If you, I mean, mine's right. An
I'm so
L.
proud of you for knowing.
You making fun of my L?
That's not a triangle, it's an angle.
1, 2, 3,
Oh,
4, 5.
never mind.
All right. Somebody, we're doing distance. Wait. No.
1, 2, 3, 4, 5.
Speed over. Well, I just say speed.
Does it matter?
As you're traveling, speed, right? All right. Somebody give me a speed that we want to drive steady at.
70.
60. I heard 60.
287.
I heard 60.
62.
I heard 60.
62.
So, if in the first hour, hour 1, you average 60 miles an hour, maybe I should just put 60 here?
Sure.
Could I?
Yeah.
Could I put 60 down here?
No.
Why not?
You start at 0.
You do not have to start at 0. Who told you have to start at 0?
Miss Math teacher I've ever
You
had.
do not have to start at 0. Now, your math teacher in the past, if you were doing like a standard cross, like quadrants,
Yes.
the center would be 0. But on a graph like this, you do not have to start. If your values aren't anywhere near 0, you'd have a lot of empty space, wouldn't you, if you started at 0? So you don't have to start at 0. So I could put 60 down here, right? Now, I'm not going to.
Well, if you
I'm going to put it on the first one, though. Okay, and then if I just do 120, 180, what was that, 240, 300, and that'd be 360, right? If I'm just counting by 60s. And I wouldn't have to. I can count by 50s, but this is just really easy since we're saying 60 miles an hour. So this is the distance in miles. So if we're starting off at 60 miles per hour, the first hour we did 60 miles, right? First hour, 60 miles. Let's say we maintain 60 miles an hour for the next hour. That's the average speed. So we got hour 2. We did another 60 miles, now we're up to 120 miles. What is my line looking like if I'm maintaining a steady speed?
a line.
Is it straight or curved?
Straight.
Straight. If I'm maintaining a steady average speed, my line should look relatively straight. However, if I slow down, will I be covering more or less ground? Less ground. So if after hour 2 my average speed decreased, I would expect to see that at the next distance mark, or at the next time mark, I wouldn't be all the way up to that next distance. And what you'd see is that line would break, right? It would turn, okay? And then maybe I maintain that speed for a couple of hours, and then maybe I speed back up for the last one. Yes?
Oh wait, never mind. Maybe that was dumb.
So if you're covering less distance in the same intervals of time, you're going to be here, you're going to be slower, and then you're going to be steady again, and then now you're covering more ground again, so you're doing what? I slowed down, and now
You're
I'm
gonna accelerate.
speeding back up again.
Say that we were at 180 miles per hour.
Yeah.
We could never go back down to just go.
You would have already covered that distance.
Yeah, so you
Yep.
can't go back down to 60.
Right, exactly. You can't go back down for distance. Now your speed, because if I look at this and I say, okay, from here I was at 2 hours, from 2 to 3 hours, that's 1 hour a time.
Yeah.
How far did I go? I only went, let's say I went 20 miles in that time. I was only going 20 miles an hour for average. Maybe I stopped to take a leak. Who knows, right? Right?
Yeah.
Okay. Or my car needed some fuel. Whatever. Does that make sense? Does everybody see this? Does it make sense to everybody? This is kind of a speed representation on a graph. So if it's a speed graph, you need distance and time on your x and y axes.
Okay, that's not that bad.
Not that bad at all, is it? Do you want me to break your brain?
No.
All right, I'm going to break your brain now. All right, here we go. In fact, you said something that I find interesting. You said, oh, you accelerated. Hold on.
I did say that, y'all.
Velocity. This is a definition. Put it in your notes. Velocity is speed
Velocity.
and direction of travel.
Wait, I can't find your
I gotta be there until I finish writing, and then I can get out of your way.
Okay.
So velocity is speed, which is distance divided by time, right? So velocity is distance divided by time, but it also refers to your direction of travel. So, if I wanted to drive to Cincinnati, are you guys listening?
Yeah.
If I want to drive to Cincinnati, I might be driving at 80 miles an hour up 71 to Cincinnati, but I'm also going which cardinal direction? North,
South.
east. Northeast.
Well, I thought it was never.
So I would say, hey, 80 miles an hour northeast. That's my velocity. Does that work? Does that make sense? Okay. This is very important. Velocity is not just speed. It's speed and direction of travel. All right, check this out. This is going to blow your brain. Are you ready? All right. Acceleration is any, and underline the word any, change in velocity.
So even if I decrease.
Yes, even if you're slowing down, that is acceleration. When we represent it with numbers tomorrow, it'll be a negative number. Does that make sense?
Yeah.
So if you're speeding up, you're accelerating. If you're slowing down, you're accelerating. But wait, it also says velocity is direction of travel. So if you're maintaining speed but you're turning, so if I'm going this way and then I'm going this way, I just accelerated.
Wow.
It doesn't have to be a change of speed to be acceleration. It could be change of direction of travel.
So it's just vague. Way to say.
You're gonna know what it is, but it could be direction of travel. It could be, you could think three-dimensionally too. If you're in an airplane and you're flying steady at a speed and you're not turning left or turning right, but you go up in altitude, didn't you just accelerate?
Yeah.
Yes, because on a three-dimensional scope, you have changed direction.
Oh.
Yes.
So, if say like you're walking forward and you just go backwards, you're still accelerating. So.
Yep. No, actually, if you're walking forward before you go backwards, don't you have to slow down to a stop? You just accelerated. Negative acceleration. And now going backwards, you're doing positive acceleration to get back up to speed. Does that make sense? Crazy, right? We don't think about it in common language that way, but that's true.